can separate metric number DD1779. For my part, in equilibrium of force experiment, I will explain about additional theory and result. A very basic concept when dealing with force is the idea of equilibrium or balance. In general, an object can be acted on by several forces at the same time. A force is a vector quantity, which means that it has both a magnitude and a direction associated with it. If the size and direction of the force acting on an object are exactly balanced, then there is no net force acting on the object, and the object is said to be in equilibrium. Because there is no net force acting on an object in equilibrium, then from Newton's first law of motion, an object at rest will stay at rest, and an object in motion will stay in motion. In example on the figure, it shows a blue ball that is being pushed by two forces. Label force number 1 F1 and force number 2 F2. Remember that force are vector quantities and direction is important. Two forces with the same magnitude but different direction are not equal force. In fact, F1 equal to negative F2. In example in the figure, there was an increase of the magnitude of force F1, so that it is much greater than force F2. The forces are no longer in equilibrium. The force equation remains the same, but the net force is not equal to 0. The magnitude of the net force is given by F1 is greater than negative F2, that F1 plus F2 equal to F net. This is the result for the experimental. And lastly, this is the result for calculated.
Assalamu alaikum. My name is Muhammad Ammar bin Muhammad Abdul Wahab, CD180130, and today I would love to talk about observation for experimental equilibrium of forces for Lab 2 static. Okay, from what we have observed in the experiment, W3 is supported by another two cords passed over the pulleys, which will then create an angle that will carry according to the loads used for each experiment. When the system is bounded and jogged, the system is allowed to move freely and settle down to its equilibrium position. The friction on the pulleys are assumed to be neglect. In fact, this neglect friction may affect the overall experimental results. For first experimental, W1 is equal to W2 equal to 2 Newton, and W3 is equal to 2.5 Newton. It is observed that the angle theta and theta1 and theta2 is the same when the system is in its equilibrium position. This is due to the fact that W1 and W2 is equal in magnitude of weight. The force in the left hand side and the right hand side is equal in magnitude but in opposite direction. For the second experiment, and then that is W2 is equal to 2.1 Newton and W1 is equal to 2 Newton. This time, W2 is bigger than W1. Thus, it can be observed that the theta2 will be slightly smaller than theta1, as more force is acting toward the left hand side in order to achieve the equilibrium condition. Next, as the W2 is increased for the following experiment and the increment of 0.1 Newton until W2 is equal to 2.5 Newton. It can be observed that theta 2 decreases after the system achieves its equilibrium position. Meanwhile, the theta 1 is increased as the weight of W2 is increased. The system tends to move toward the left-hand side as the force in the left-hand side is greater than W1. This is only valid when the system is jogged and settled down to its equilibrium position. Last but not least, the cord at W2 is being pulled downwards as more load is applied at W2. In overall, W1 and W2 are the constant variables, whereas W2 is a manipulating variable. Also, as the weight at W2 increases, it can be observed that the ring moving towards up left region after the system achieved its equilibrium position. Besides, the system is stopped at different equilibrium position for each time the system bounced with different W2. Lastly, the pencil dot is marked on the attached paper carefully, as when marking the position of the cords on the paper, the equilibrium position may change if it is touched. Okay, that is for me today. Thank you.
Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh. So my name is Muhammad Bayaki bin Abdullah Aziz. Today I'm gonna give the explanation for calculation on my lab report that titled The Equilibrium of Force. So the report wants us to find the angle of angle 1 and angle 2. So it is given the force on every 5 experiments. So when weight equal to 2.2 Newton, by using the formula cos equal to adjacent per hypotenuse, we will calculate the angle for angle 1, and with the same formula we will calculate the angle for angle 2. So for angle 1, when the weight is 2.2 Newton, we use inverse cos 2.0 square plus 2.5 square minus 2.2 square over 2 times 2.0 times 2.5. So the answer is 57.2 degree. So we will use the same formula when weight equal to 2.3 Newton, 2.4 Newton and 2.5 Newton. So next we will calculate the length of OC by drawing a force diagram. So with the scale 1 cm equal to 1 Newton, we will draw a force diagram. First, we must draw the angle that is we will get from by running the experiment. So for weight equal to 2.0 Newton, we use angle 1 and angle 2, that is theta 1 and theta 2, and then by using scale 1 cm to equal to 1 Newton, we will draw a line straight, and the line intercept, we will draw the line from 0 to C. So from that we use ruler and measure the length. So the length of OC is 4.87 centimeter. We will use the same step to do when weight equal to 2.1 Newton, 2.2 Newton and 2.3 Newton. The angle for angle 1 and angle 2 is given in the result when we running the experiment we will get the angle by using protector. I think that's all for me. Thank you.
Discussion. Based on the graph of W1 over W2 equal F1 over F2 against sin theta over sin theta 1 plotted for both experimental and calculated results, the graph shown the linearly proportional line for both experimental result and calculated result. For the experimental result, the line of base fit passing through the centroid is obtained and the gradient of the graph is 0.495. While for the calculated result, the gradient of the graph is 0.993, which is approximately equal to 1. This means that the gradient of the graph from the calculated result perfectly follow rule as stated on Newton's law of motion. There is a difference between the gradient of the graph of calculated result and the experimental result. The percentage of difference between two gradients are 50.15%. This percentage of difference occurs as the random error such as parallel error and systematic error during the experiment. Meanwhile, the calculated result assumes that no error is occurred. Conclusion. Throughout the experiment, we have a better understanding to the concept of the equilibrium of the force. Three non-parallel forces in the same plane that in equilibrium are also investigated, and we notice that their line of action will meet at point. Then we know that a parallelogram of forces can be used to find out the resultant of the two forces. Moreover, we are able to determine the resultant force using the Newton's law of motion. In fact, the resultant force obtained from the non-parallel forces F1 and F2 have the same magnitude with F3, but in opposite direction. This explains that the system remains in equilibrium due to the force of F3, which makes the resultant force of system equal to 0.